Hi students, welcome back. Coming to our next topic, that is two-phase locking, 2PL. So this is one of the concurrence control technique. So the two-phase locking is one of the concurrency control technique. So let us see what is this two-phase locking. Actually, this two-phase lockings requires both locks, both locks and unlocks being done in two phases. So that's why we call it as 2PL. It requires both locks and unlocks, okay, being done in two phases. So first what it does, it locks all the transactions. After the completion of the operation, it releases all the locks, that is unlocks. So it does two operations in two phases, so locks and unlocks. That's why we call it as a 2PL. Okay, so actually there's the two phases, locks and unlocks will be the 2PL is divided into two phases. One is growing phase and another is shrinking phase. So the two-phase locking will be divided into two phases. One is growing phase and one is shrinking phase. Growing phase, locks are obtained but not released. So the main thing here is, locks are obtained but not released. Okay, whereas in shrinking phase, locks are released but no new locks are acquired. Okay, so these are the two phases, the shrinking phase and the growing phase. So in the growing phase, you have to be think that only locks are obtained but not released. Here you can lock the transactions but you can't release in the locks in growing phase. Coming to the shrinking phase, shrinking means getting down, means here the locks are released but new locks are not acquired. Okay, no new locks are acquired in shrinking phase. So that is the main difference you have to be noted. So here the locks are acquired and here locks are not acquired. No new locks are acquired and here locks are acquired. Locking the phases and then releasing the locks. So this is a two-phase. That's why you call it as a two-phase locking. So actually this two-phase locking will have a common point. That is the lock point. Okay, so lock point. What is this lock point? Actually the growing phase will locks all the transactions and it comes to the final lock. So it's saying it is a final lock. So after lock point, the growing phase cannot allot in new locks. The main thing you have to be noted here, the growing phase and the shrinking phase. In the growing phase, the locks can be obtained. Okay, you can't release the locks, only you can allow the locks. New locks are allowed here. Whereas in shrinking phase, whatever the locks that made in the growing phase are released here. But here you cannot allow the new locks. Okay, so in between them one lock point is there. So when this growing phase will know that how to stop the lock process. So whenever it sees the lock point, means that is the final lock to the growing phase. So after that lock point, the shrinking phase onwards, it release the locks. So whenever it sees the lock point, the shrinking phase is thinking, okay, now I can release the locks, whatever the locks that growing phase is created. Okay, so this is the two-phase locking. And the two-phase locking protocol and for serializability, but may reduce concurrency due to the following reason. I said it is a concurrency control technique. How we can say this two-phase locking is a concurrency control technique? Because it holding lock unnecessarily. Why it is holding lock? Because it creating a security to the means it is not allowing other transactions to see these transactions. Okay, so holding locking too early. So this two-phase locking is doing the locks too early, so that conflicts may not occur. Penalty to other transactions. Okay, so these are the 3 points will reduce the concurrency due to the in the two-phase locking: holding lock unnecessarily, locking too early, and penalty to other transactions. Okay, so let us see the graph, how this growing and shrinking phase is okay. So let us see here the graph. So 1, 2, 3, 4, and this is 5. Now it is shrinking. 6, 7, 8. So this is a time. Okay, so here you call it as a start point. So this is a start point. Okay, and this you call it as end point. So start of the transactions and end of the transactions. So in between here you are having operations will done here. So when it operations will done, okay, so it is this you call it as active lock. This you call as active lock. And here this is the lock point. So I said whenever the growing phase sees a lock point, it stops creating the new locks, final lock. So after lock point, what it does, now the shrinking phase is releasing the locks. Release locks, release locks. Okay, so like that. So first, this you call it as a growing phase. So this is growing phase and this will be shrinking phase. In between this, you are having the locked point, locked phase. You call it as a locked phase. Okay, is it clear? So this is the flow, means the diagram, pictorial representation of the two-phase locking. Here we have taken the 8 transactions here. So whenever you're creating, it will be whenever the lock will be is there, it is in active state, means the growing phase will be active. So whenever this growing phase will see the lock point, it stops creating the locks, and now the shrinking phase is allowed to release the locks, whatever the locks that is created by the growing phase. Okay, so this point you call it as a locked point, locked phase. Here the operations will be done. Okay. Okay, now let us see the variations of, so before going for the variations of the two-phase locking, let us take one example how the two-phase locking will work. So here the two-phase locking, like let us take 2 transactions, T1 and T2. Okay, so first what is there? First lock, create a lock, growing phase, lock A. After you are allowing, you are locking the A transactions. Now the T1 transactions is ready to read that lock. Only the T1 can able to read that lock. After that, A is equal to A plus 100. One operation has done, and then write lock. So after writing, again you lock another data item. So in this transaction, one data item is locked. Okay, and he does the operation and it writes that data item also. And then lock B. Now unlock the A. Okay, so when you will done this unlock, after completion of all locks only you can done unlock. After completion of all locks, okay, then only you can unlock. So after unlocking the A transactions, you are not allowed to create another new locks. Okay, so when you are starting unlock the operations, means you are coming to the shrinking phase, you are not allowed to go back to the growing phase. You are not supposed to, means the transaction, you means here the transactions are not supposed to create a new locks. Okay, first it locking one data item and it is doing the operation, and then it create another data item. The transaction is locking another data item. After locking the another data item, it releasing the first data item. So whenever it release that, this transaction is not supposed to create new locks because it enters into shrinking phase. Okay, so after that it is reading the B, so which already locked. Okay, reading data item B is equal to B plus 100 and then write B. Now unlock the B. Okay, so this is the two-phase locking in the transaction T1. The transaction T1, what it does, first it locks the it locks the transaction. After that it releases the lock. Okay, so here also it locks the transaction and it releases the lock. Okay, so here the L1 is doing the operation, means the lock on the particular data item, it reading the data item and that writing the data item. Here also L1 locking the data item, reading the data item and writing the data item. Okay, now coming to the T2 transaction. So here is a L2A. So after that it R2A reading the data item. A is equal to 2 star 8 is doing another operation and write the A value. So here what you have to create a lock before unlocking the data item. The transaction is going to create another lock on another data item because one operation is over. So it's supposed to lock another data item before releasing that lock. L2B, now unlock this data item. R2B, B is equal to 2 star B. Now write the data item B2. Unlock this data item. Okay, so these are the here first unlocking, locking and unlocking the transaction data item, and here this is locking and unlocking the data item. So after it is reading the locking the data item, reading the data item and writing the data item, locking the data item, reading the data item and writing the data item. Okay, here all lock operations precedes all unlock operations. You can see the difference here. All lock operations precedes all unlock operations. Okay, so that you have to be noted. All lock operations precedes all unlock operations. So before unlock only all lock operations are there. So this is lock and this is lock. After the lock only you are releasing the locks. Okay, so this is the two-phase locking protocol. So the variations in two-phase locking protocol, just I am giving the brief idea about this. The variations of two-phase locking protocol. So the variations here are, first is the conservative, you call it as a static two-phase locking, strict two-phase locking and rigorous two-phase locking. So these are the variations in two-phase locking protocol. In conservative static two-phase locking, here acquires all locks before it starts. So before it starts, it acquires all lock and releases all locks after committing. After committing only, after commit only, it release the locks. After commit only, it release the locks. So here it avoids cascading rollbacks, and it is also the deadlock free. Now coming to the strict two-phase locking. In the strict two-phase locking, exclusive locks cannot be released until commit. Okay, until commit. Until commit, here exclusive locks cannot be released. So that you have to be noted here in the strict two-phase locking. Until commit, here exclusive locks cannot be released. So it also helps in cascadeless schedule, and here deadlock may occur. Here it is deadlock free, whereas in strict two-phase locking and rigorous two-phase locking, in these two cases deadlocks may occur. So rigorous two-phase locking, shared or exclusive locks cannot be released until commit. Okay, so here shared or exclusive cannot be released until commit. So here also it is not releasing until the commit. So that's why these two cases, in strict two-phase locking and rigorous two-phase locking, deadlock may occur, and here the conservative two-phase locking is the deadlock free. Okay, thank you. This is about the two-phase locking protocol.